Hello children, welcome to channel Sube. Children, today I am going to discuss question number 42 from the MCQ part of 2021 Physics new syllabus paper. An open copper vessel of mass 2.0 kilogram is at a temperature of 150 centigrade degrees. Water of mass 0.1 kilogram at 25 centigrade degrees is quickly poured into the vessel. What is the mass of water converted into vapor? Assume that there is no loss of heat to the surroundings. In brackets, take specific heat capacity of copper 400, specific heat capacity of water 4000, specific latent heat of vaporization of water is 2.5 times 10 to the power 6. Answer: the first one 1 gram, the second one 2 gram, 3 gram, 4 gram, 5 gram. So children, first of all let us draw a little sketch to describe this problem. So the copper vessel I draw like this, and water in a container is poured into this vessel. So the temperature is 25 of this water, that is the theta. So the mass is 0.1 kilogram, 0.1 kilogram. So specific heat capacity is given 4000, not 4200 as usually we use. Remember, otherwise you get confused that and you get the wrong answer. So this copper vessel has a mass of 2 kilogram. The temperature of it is 150. Specific heat capacity is given 400. 10 power 2 is 400, 4 times 10 power 2. So these are the data. So what happens when we, so this one is heated up to 150, so that is considerably higher temperature than 100, because you know at 100 centigrade the water begins to vaporize, boil, and vapor is made. So converted into vapor, that is what they ask. So the first step is water goes to 100 degrees. All the water goes to 100 degrees, because to happen anything beyond that, first it has to be at boiling point. So first the total mass increase its temperature to 100 centigrades. That must happen. So after that, if there are additional heat coming from this vessel, because it is the source of heat now, because it is at the higher temperature. All other temperatures are lower than that. So this one is the highest temperature in this system object which has the highest temperature. So from that all other people take heat. People means this water take heat. So after that we can divide into steps like this, but practically it happens at once. But for our convenience, let us draw like this. So after that, if there are more heat coming, so some amount of water is converted into vapor. So that mass is what we have to find out. So this one is the vapor. What is the mass of water converted into vapor? So here let us suppose this mass of vapor is m. So L they have given. L they have given as 2.5 times 10 power 6, but we can write it 25 times 10 power 5 instead of 6, 5, because then it is easier. We can simplify easily because there are other numbers 150 and also 25 here. So if we write this as 25, then I think it will be easier. So what is the principle now we are going to use to calculate this mass? The principle that we are going to use is conservation of energy. Especially heat energy. That means heat gave is equal to heat absorbed. Who give heat? Who gives heat? Who gives out heat? The people who are at highest temperature. So we have to find the heat. Who gives heat? The material who has the highest temperature. So in this case, this one is at 25 and this one is at 150. So this one is the material, that means this jar, what they call vessel. So this vessel is the one who gives heat because it is heated red hot, because it is over 100, so it is considerably heated up. So that vessel is the one who gives heat to this water because it is at highest temperature in this case. So we have to write ms theta therefore. So we can write it later. So this one is the, so we have now identified who is giving heat. So who is absorbing heat? Who is absorbing heat? The materials who are at lower temperature. So here in this case only one material, only water is there. So it is at 25 centigrade. So that is the that is a lower temperature than this 150. So therefore water absorbs heat. Water absorbs heat. Then after that we have divided into two steps. So this water absorbs heat. Then what happens? This vapor also absorbs heat to change its state from 100 centigrade water to 100 centigrade vapor. So that is now we can write vapor. Vapor also absorbs. Water absorbs. Vapor absorbs. Then here we have to write what? The container, copper container. They have said copper vessel. Copper vessel is the one who is giving heat to the system. So now we have written in words. So we have to write equations. So since the copper vessel doesn't change its state, no change in state for this copper vessel. Therefore the term ms theta we have to write. Then equals for water must increase its temperature first to 100 degrees, so no change in state. In that step no change in state, so therefore ms theta term should be there, plus this one. Now vapor, to convert from 100 centigrade water to 100 centigrade vapor, that needs energy, that is given by ml term. We know that is ml. L is latent heat, specific latent heat of vaporization of water, so that is given. So no temperature change, therefore no theta term here. Even though we write theta, you must remember it is theta 2 minus theta 1. Just for convenience we write just theta, the other thing is in our head. So now we have to substitute. So for convenience let us copy these things, data, this amount of data here, so we can easily substitute. So we are going to substitute for this copper vessel ms theta term. M is 2 kilogram, S is 400, theta 2 minus theta 1 is 152, initial temperature has been 150, final temperature is this one 100. So minus 100 means directly we can write 50 without brackets, 50 equals, that is the only term we get for left side, that means who is giving heat away, who is giving heat to water or to the system. So ms theta is for water, this one is for water. Therefore let us copy this portion of data, keep it here, so we can write m first, m is 0.1, let us use the same color, 0.1, this one, S is 4000, then theta 25 to initial temperature has been 25, the finally 100, so difference is 75 degrees. So 75 degrees times 75, then that term is okay. Then ml term, ml means for this mass of vapor, so we have taken as just m, so that is what we have to find out, what is the mass of water converted into vapor. So therefore we have to write m. L is given as this one, 25 times 10 power 5. Now we have to simplify. Let us simplify first 25, divide by 25, then 1, here 3, divide by 25, here 2. Then let us cancel zeros, there are 2 zeros here, 2 0 from here, 2 0 from here, then 10 power 3. So 4 times 2 is 8, 8 times 2 is 16 equals, here 0.1 times 40 is just 4, then times this 3 plus 1000, 10 power 3 is 1000 times m. So 4 times 3 is 12 plus 1000 meter. So we have to find out this one, we have to isolate it, so we have to take it this to this way. Then 16 minus 12 is 4, no, yes 4 equals 1000 m. So m equals 4 divided by 1000. What are the units? Kilogram. But in the answers there are grams, so therefore we have to multiply this by 1000, then the 1000 cancel at the denominator, so 4 grams. The final answer is 4 grams. So this one should be the answer. Let us check it. Question number 42, the fourth one. Right, we have successfully solved the problem. So children, this is not a big issue actually. If you have practiced, if you have done these types of calculations. So I have designed a target question for you, because next time you won't get the same problem, because these are past papers. So some little with some little change, this will come to you when you sit for the exam next time as a new problem. So sometimes they change a little from the past papers, sometimes they design entirely new questions. So assume you are lucky to have this question with little change, little alterations. Here children, I have converted the problem into a target question with little alterations. So what now you have to do is pause the video and read the question properly and try to answer it on your own, but don't watch my video before answering. After finding the solution, you can watch the video. So now pause the video. I think you have found the answer now. So I am going to solve this one. So as previously, we have the vessel, the water container. So what happens? The data they have given: copper vessel has 2 kilogram mass, temperature is something above 100, we don't know, therefore we have to take it as theta. So that is what they want us to find out. What was the temperature of the copper vessel? So specific heat is given 400. So the mass of this water is 40 gram, therefore times 10 power minus 3. S is given 4000 and theta is 25. So correct. Then we have to find out this theta. So what happens if the total mass of water is converted into vapor? The first step is this total amount of water should increase. It is temperature to 100. Thereafter it can convert into vapor or happen anything, but first of all it has to be increased, heated up to 100 degrees without change in its state. So then thereafter what happens? The next step, so all these things happen together, but for our convenience we split this total incident into 2 steps. So the vessel is there empty, so all the water is now converted into vapor. So like this. Now we know the mass of the vapor, so that is total amount of this water. So this one, so that was previous one. So water amount of water is 40 gram. So we know that, therefore we can write 40 times 10 minus 3, so that is the M. So temperature must be 100, we have to assume that. So they have given L 25 times 10 power 5. They have given 2.5 times 10 power 6, but I write it as 25 times 10 power 5, because we can cancel easily this other values. So let us write the equation. ms theta is what? The heat given from this vessel, So to this vessel, ms theta gives heat out. So ms theta means 2 kilogram 400, that is says theta. Theta is that we don't know, even though we say theta, you know, theta 2 minus theta 1 here. In short, we say theta. Theta means, then this theta is a higher value, then it converted into this value 100. Here also 100, 100, because beyond that it can't go. Since there is water, it can't go, it can't go than 100. So here theta minus 100, because the higher temperature is theta, so minus 100, then we get the change. Then equals, who absorbs heat? Water. Then ms theta. Water has not from here to here any change in its state, therefore we can write ms theta term. ms theta, m is 40 times 10 power minus 3, s is 4000, then theta 2 minus theta 1 means theta 2 is 100, theta 1 is 25, so 100 minus 25 is how much? 75. That is the temperature change. Then plus this total amount of water converted into vapor, so that also absorbs heat, so therefore ml term we have to write. M is this total mass, 40 times 10 power minus 3. L is 25 times 10 power 5. So we have finished writing the equation. Now what we have to do is simplify. So let us simplify first this 25, and 25 3 times here, 200 4 times, then 4 into 4 16 times, then 2 times 16 means 32, theta minus 100 brackets, then this minus 3 cancel with this plus 3, then here minus 3 cancel with this plus 5, so remaining 10 power 2. So what we have get here, 40 times 4, this 4 times 3 plus here 40 times 10 power 2, 0 0, 10 power 2, 4000, 10 power 2. So we can divide by 10, so this one cancel, this one cancel, this become 3.2 times theta minus 3.2 times 100 means 320 equals 4 times 4 16 times 3, that means 48, 48 plus 400 plus 48 means 448, 448. So here only 400, this 0 is cancelled. So here we take this one to the right side, then we have to take the sum. 8, 6, then 7. Here 3.2 theta. So theta equals 768 divided by 3.2. So I am going to use the calculator, but you are not allowed. Remember, children are not allowed to use calculators, but teachers can. So divide by 3.2. You have to divide in the normal way, manually. 240 centigrade. That is the temperature. So here is the answer, the second one. If you have successfully choose the correct answer without watching the video, then if you are correct, we can say you are good, you are a genius, you are a genius son. Very good. If your answer is wrong, then you have to work little bit harder. You have to solve more problems. You have to read your notebook at least several times, and try to get those things into your head, not on the paper. Children, here is the target question 2. So now you have to face it. So pause the video, read the question properly, and try to answer it on your own. Don't watch the video. Pause the video now. So I think now you have done. So I am going to try this question. So the vessel is there, and I have to draw 2 vessels after the incident, like this, and then this one turn to this one. So the water is poured like this. So mass, some mass, m, that is what we have to find out. So initial temperature is 25 as previous. Specific heat capacity 4000. Regarding this copper vessel, the temperature is 150 theta. Mass 2 kilogram. Then specific heat capacity is 400. So first of all, what happens? The water, total amount of water should heated up to 100. After that, anything can happen, but before that it should, as water, as liquid, without a change in state, it should increase its temperature up to 100. So if there are additional heat, then what happens? It converts into vapor. So like this. The total mass, they say, if the total mass of water is converted, so that means the mass, here we can write, we don't know that is what we have to find out. So let us assume that this symbol m, say it is m. So this m is taken for the total amount of water. So here also, because they say that total amount of water is vaporized, so there is no water in this vessel now. So all the water is now as vapor, appears as vapor. So the mass same, total mass is taken as m, so that m is here 2. So now let us write equations as previously. This one is the heated one, so that this vessel is the one who is giving heat. So therefore ms theta, it doesn't change in its state. If the vessel is not changing its state, just we have to write ms theta, not ml. If only change in state, then only we have to write ml part. So m is 2 times 2, ms is 400, theta is 150 to 100, then 50, change of temperature is 50. So who is absorbing heat? Water. then ms theta up to this level. After that we write ml term, but we are now writing only up to increase its temperature to 100, not beyond that. So m is that we don't know, so we write m. S is 4000 times 75, 25 to 100, 25 to 100, 75. Then plus ml term now for this vapor. So total mass, then simple m, L is 25 times 10 to the power 5. It is 6 if we write 2.5. Now let us cancel 25 3 times, 2 times, then cancel 20, 20 here, 20, then 10 power 3, then 16. 4 times 2 is 8, 8 times 2 is 16. Then here 40 times 3, 120 times m, that is all. Here 1000, 10 power 3 means 1000 m. Then totally 1120 m is equal to 16. So m equals 16 divided by 1120. So I am using the calculator, you are not allowed to use the calculator. So you have to manually divide. 0142 units kilogram. So if we multiply it by 1000, we get the amount of gram, 14.2. Here first one is the answer. What happened to you? Correct? Correct. Then you are genius, you are genius. You have understood about this thermometer, not this heat capacity. If you are wrong, you have to do more exercises. So children, now I am going to wind up the video. So you must be happy, children, because I have done extra target question, extra 2 target questions like this, and I discussed the original MCQ question also here like this. So you must be happy. So you have to make me happy also by subscribing my channel if you haven't still subscribed. So press the bell icon also, give me a thumb up, and share my link with your friends. Then see you tomorrow. Goodbye, children.